Good afternoon, everybody. This is Tim Zinnel with Zinnel Electric. We're up here today shooting a little video of a project that we're just finishing up located by Clearwater, Minnesota. As you can tell, this is a very large solar field. It is a 7 megawatt DC solar field. 7 megawatts DC and 5 megawatts AC. Covers a lot of area. It actually covers, for solar panel wise, about 30 acres. And the whole site overall covers about 35 acres. Now, as I mentioned before, this is a 7 megawatt or DC 5 megawatt AC field. It actually consists of 5 separate systems. We have 5 1 megawatt services here. And when I say that, that means 5 separate services feeding into the grid of 250 amp, 2,500 amp at 480 volt. Hello again, this is Tim Zinnel talking. So we're going to kind of explain how this system works. Typically, when we're getting our power, we get it from the power company, goes through a transformer. From the transformer, it comes into our house through the meter to a service panel, and from there it branches out. Well, with the solar project, and with the solar system in particular, we actually have to think of things going a little bit backwards. So we're actually going to be starting at the point where the power is generated, and that's right here at the solar panels. As I mentioned, we have over 20,000 solar panels that are on this project. These are 350 watt REC, that's a manufacturer solar panels. As you can tell, they're mounted in portrait and they're too high. So we have a very long array of solar panels here. So as the sun is hitting the solar panels, there's semiconductors in there, and electrons are moving around, pushing them from one side to another. That's where electricity comes from. It's the movement of electrons. From there, they travel on the wires. And here's the wires that's actually coming from the solar panels. As you can see, they're coming in, they're going underground, moving over to the next part that we're going to be showing you, the panels and the inverters. So as the power is generated, it's going through the wires, it goes underground, then it comes back to something like this. This is your typical grid-tied inverter. On this project, we actually have 90 of these inverters. So, and to kind of give you a breakout of how things are connected, we have 90 inverters. Each inverter has 13 strings of 18 modules. So if you do the math, we're looking at roughly, let's see, 180, say over 200 modules per each inverter. Now these are a 60 kW inverter, and when we're talking about, say, kW and megawatts and things like that, K stands for 1,000. So if it's 60 kW, it would be the same as saying 60,000. As I mentioned before, 7 megawatts or DC or 5 megawatts AC, that'd be 7 million watts DC and 5 million watts AC. Now, after the power comes to this point, now that's in the DC form. This is the part that actually transforms it from the DC that's generated from the panels to the AC power that we actually utilize. So this is where the conversion is done, and at this point, then again, it goes underground, and it brings us over to our AC combiner panel, which is located right here. We open this up, and we see that we have various breakers, which is from all the different inverters, and this is where the AC combining part takes place. It combines everything into one, what we call a feeder, and from this point, it then goes back to our main service panel. Alright, so once we combine all the power from our inverters, we're coming back to our main service. This here is part of that 2,500 amp main service panel that I was talking. As you can see, we got actually 4 panel boards that are coming here and combining again and going to our 2,500 amp service, which is actually located over here on this port right here. So that at this point, we have 2,500 amps worth of power. Now from this point, we're actually going again backwards, and we're coming over to what is called the CT cabinet, where the actual metering is done by the Xcel Energy, the utility. As you can see, we got parallel sets coming into at this point, and this is where the metering is done. This is what's called a CT or current transformer. That's a way of metering or keeping track of the amount of power that is produced for the utility company. Now from this point then we actually move on over to our transformer. that, we utilize a monitoring system. This is a typical monitoring rack. The monitoring here is actually done by Also Energy. They're the suppliers of the monitoring equipment. At this point, it actually connects to the internet, and all 5 services are connected together, and we're actually able to monitor what the system is producing online wherever you may be in the world. So again, Tim Zinnel, Zinnel Electric, on a 7 megawatt DC, 5 megawatt AC system. Thank you very much.